So what we'll look at in this video is comparing two means. We previously constructed confidence intervals and performed hypothesis tests for mu. For example, a social scientist may claim that students who are members of a certain social media site have a mean GPA less than 3.1. To test this claim, we form a hypothesis, we collect our sample of size n, we calculate our test statistic, and then we make our decision. Okay, so that's back from previous topics. So if we were to write HO and HA, the null and alternative hypothesis for this example, well, HO, the null hypothesis, that always contains your equals, okay, your equality, and we're saying that the mean GPA less than 3.1, so HO will be that mu equals 3.1. Okay, so the mean GPA of all students, the population, we're hypothesizing or guessing that the population mean is 3.1. So the alternative hypothesis will be mu. Well, they're trying to say the mean GPA is less than 3.1, so that less than goes in our alternative hypothesis as mu is less than 3.1. Okay, so the way we read that, the population mean of all students that use that social media site have a GPA of less than 3.1. Okay, and then what we would do is we would either form our confidence interval or conduct our hypothesis test by collecting our sample of size n, calculating the test statistic, and then making the decision. Okay, what we're going to look at now is looking at comparing two means for two distinct independent groups of individuals. So suppose the social scientist claims that the mean GPA of students who use the social media site is less than the mean GPA of students who do not use the social media site. Okay, so they're basically looking at if the students use that social media site, their GPA is less than those students that do not use the site. Okay, so maybe they're assuming that the students are more distracted, or maybe they have more things going on, or less time to devote to going to doing homework. Okay, maybe something like that. Okay, so they're looking at a null and alternative hypothesis. Instead of trying to say that the population mean is a certain number or less than a certain number, now we're saying is the mean GPA of students who use the site is less than the mean GPA for students who do not use the site. So what we're looking at is that mu1 is equivalent to mu2, okay, for the null hypothesis. So that would be mu1 representing the students that use the site, and then mu2, the average GPA of the students who don't use the site. So the alternative hypothesis will be that mu1, those that use the site, is less than the GPA of those who don't use the site. Okay, so again, this is the major difference when you compare two means compared to what we did before. Okay, again, before you were looking at mu being equal to a specific number, or less than a certain number, greater than a certain number, not equal to a certain number. Now we're looking at comparing two means, okay, one mean against another mean. Again, it's important to note that these are two distinct independent groups of individuals. Okay, so the students, you're not going to have students that use the site and don't use the site. They either do or they don't use the site. Okay, so these will be two distinct groups of individuals. Okay, so the process we use will be the same, okay, the same concept, except there's a few differences in some of the formulas. Okay, but the concept is the same. Okay, so there's just some terminology and formulas to get into here. So to test this claim, we need to take a sample of students from each of the populations. One sample will be from the populations of students who use the social media site. Okay, so we're looking at one group of students who use the site. We're going to take a sample from that population. And then the other sample will be from the population of students who do not use the social media site. Okay, so that'll be another sample. We can calculate the sample statistics for each sample. So x bar 1 will be the sample mean of the users of the site, and S sub 1 will be the standard deviation of the users. X bar 2 will be the sample mean of the non-users, and S sub 2 will be the standard deviation of the non-users. Okay, and remember, these are all samples here that we're looking at. Okay, the sample sizes, N1 and N2. Okay, so N1 will be the sample size of the users, and N2 will be the sample size of the non-users. Okay, they do not need to be the same. Okay, so you do not have to have the same sample size for the users and non-users. Okay, and that's good. However, the samples must be independent and two simple random samples from two distinct populations. Okay, and again, the idea there is the student, you're not going to have students that use the site and don't use the site. So you're not going to have a student included in both of the samples. Okay, you're not going to have like X bar 1 and X bar 2. You're not going to have the same students involved in each of those. Okay, both populations must be approximately normal, or N1 and N2 must be large enough. And remember, this is going back to the CLT, the central limit theorem. Okay, had those few stipulations on it that you had to have an approximately normal distribution or a large enough sample size. Okay, so now we're looking at two different samples and two different normal distributions, or approximately normal distributions. Okay, so the students who use the site, their GPAs must be approximately normally distributed, and the students who don't use the media site must also have an approximately normal distribution, or both of their samples sizes must be large enough. Okay, now before, to find our test statistic, we had a one sample. And when we did a one sample t-test before, remember our test statistic was t equals x bar minus mu divided by s over the square root of n. And remember, they had degrees of freedom n minus 1. Okay, so with degrees of freedom equal to n minus 1. Okay, so that's what we used before. We took the sample mean minus mu, which was our hypothesized mean, which going back up here, it would have been 3.1, and then divided by s over the square root of n. So now for a two-sample test statistic, we have a t-score again because we know our sample standard deviations. Okay, are s. Okay, we don't know sigma. Okay, so no s. So t equals, we're going to take the difference in the means, okay, x bar 1 minus x bar 2, minus the difference in hypothesized means, mu 1 minus mu 2. Okay, so x bar 1 and x bar 2, those are going to come from the sample that we took. Mu 1 and mu 2, those are going to come from hypotheses. And then we're going to divide that by the standard deviation of the difference of the means. Well, before, the square root of this whole, looks like a really big mess here, was s over the square root of n. That's when you had a one sample t-test. Well, now we're looking at two sample test statistic. So now you got to take both of those standard deviations and samples into account. Okay, so it's not too crazy to memorize. Okay, you take the square root of S1, okay, so the standard deviation from the first sample squared divided by the sample size in the first sample, plus the second standard deviation squared divided by the second sample size. Okay, so just a bunch of substituting into that formula. Okay, but this whole thing here represents really the standard error of the difference in the means. Okay, and we're going to use the smaller degrees of freedom again. Okay, so whichever n value is smaller, subtract 1 from that, and that'll be your degrees of freedom. Okay, if you're asked to construct a confidence interval for the difference in population means, remember before, for a one sample confidence interval, it was your sample mean plus or minus t star times s over the square root of n. Okay, so that was when we knew what the sample standard deviation was. We used the t distribution and the sample standard deviation. Before that, you would have used the z star and sigma over the square root of n. But again, the concept is still the same, okay, which is why I want you to memorize the concept, not the actual formulas. Memorize the concept, and it makes this stuff a lot easier to understand. Okay, so now what we're doing is, because we have two samples, we're not just taking x bar and adding or subtracting the margin of error. We're trying to do a confidence interval for the difference in the population means. So now you have to subtract or find the difference in the sample means, x bar 1 minus x bar sub 2, plus or minus t star. Notice how that's the same. And then instead of the standard deviation being s over the square root of n, now we're looking at the square root of s1 squared over n1 plus s2 squared over n2, which was the same thing as up here. Okay, so those are how we find the two sample test statistic and the confidence interval for the difference in population means. Okay, so to get to an example of this, so looking at that previous example, suppose the following sample data is collected. Construct a 95% confidence interval for the difference in the population mean GPAs of students who use the site and those who do not use the site. So we took a sample of 128 students who use the site, and we got a sample mean of 2.97 and a standard deviation of 0.83 for that sample. And then we took another sample of size 85 from the population of students who do not use the social media site, and we got the sample mean for that to be 3.25 and a sample standard deviation of 0.42. So if we want to construct a 95% confidence interval for the difference in the population means, we're looking at mu1 minus mu2. We're trying to estimate what that difference is. Okay, so what we do, we take the x bar 1 minus x bar 2, so we can look at substituting those values in. 2.97 minus 3.25. Okay, so that's x bar 1 minus x bar 2, plus or minus our t star. Well, t star, we have how many degrees of freedom? Well, we have 128 for n1 in the sample size, and your sample size in the second sample is 85. So 85 is smaller, so we're going to use 84 degrees of freedom. So if we have a 95% confidence interval, okay, we're looking at this column in our t distribution. Okay, so we're looking at the t distribution up here. And if we have 84 degrees of freedom, we scroll down, and notice it jumps from 80 to 100, so we're going to be more conservative. So we're going to use the larger value of 1.990 instead of 1.984. That allows us to have a wider confidence interval to allow more values into our interval. Okay, so we're going to use the t star value of 1.990. Times the square root. Okay, we're going to substitute into this right here. So we have S1, which was 0.83, squared divided by 128 plus 0.42 squared over 85. Okay, so that'll give us negative 0.28 plus or minus. Now what I want to see when you do these by hand is I want to see what this number is, what the margin of error is. So the 1.990 times this whole square root. Okay, so that's all calculator work. Okay, so I'll just do this one time in the calculator to show you. Okay, we do basically exactly the way that it's entered in. And the good thing on this is the order of operations in the calculator doesn't mess anything up too much. Okay, so 1.99 times the square root of 0.83 squared over 128 plus 0.42 squared over 85. Okay, so you enter it like that, and you don't even need the parentheses around the 0.42 squared. Okay, that gives us 0.178. I'm sorry, 0.171848. Okay, so when we look at our values here, we have negative 0.28 as our estimate for mu1 minus mu2. Okay, so we're going to go out to 3 or 4 decimal places on this. I'll just use 4 decimal places, 0.1718. Okay, so there's our margin of error. Okay, so if we add and subtract that 0.1718 from the negative 0.28, okay, we end up with negative 0.4528 to negative 0.1082. Okay, so there's our confidence interval for mu1 minus mu2, or the difference in the population means. Now remember, what that means is we're 95% confident that negative 0.4528 less than mu1 minus mu2 less than negative 0.1082. Okay, so the only difference here is instead of mu being in the center, like it would have been before, now it's the difference in the population means being between those two numbers. Okay, that we're 95% confident that the true difference in population means, mu1 minus mu2, lies between these two numbers. Okay, and again, the interpretation is still the same if we did this process, like so took 100 samples from each of those populations. When we looked at estimating mu1 minus mu2, we would expect 95 of those 100 intervals to contain the true value of mu1 minus mu2. Okay, so when you look at this interval, notice how both of those values are negative. And what a negative value meant, think about where the negative came from. It came from subtracting x bar 1 minus x bar 2, or the users of the media site, of the social media site, okay, the users minus the non-users, and we get a negative number. That just means that the non-users had a larger GPA than the users did from those samples. Okay, so the fact that both of those endpoints of the intervals are negative, okay, what it leads you to believe is that it appears that the users of the site have a lower GPA than the non-users. And the difference in the GPAs we'd expect it to be between negative 0.4528 points lower and negative 0.1082 points lower. Okay, so if that interval were to contain 0 in it, so let's just suppose you did the calculations and you got negative 0.45 less than mu1 minus mu2 less than, just say that was a positive 0.1082. If that second value here is positive, then that will be telling you that 0's in the interval, which means that the difference between the means could have been 0, which is basically saying there's no difference. But the fact that they're both negative, okay, what that tells us, it appears the users, and I'm going to shorten up the wording on this, the users of the social media site have a lower GPA than the non-users. Okay, again, it's because both of these are negative, and saying that 0 is not in this interval. Again, if 0 was in the interval, then that could indicate that the mean difference, mu1 minus mu2, okay, so this minus this, mu1 minus mu2, could have been 0, which means that there would have been no difference. Okay, but the fact that they're both negative tells us that that appears that they're